Hello, my name is Hasan Mert İncesesli. I'm computer engineering student at Bilkent University. In this video, I'll go over my Physics 102 project about how temperature affects resistance. The main goal of this experiment is to observe how resistance of a resistor change with its temperature. Then I will calculate the temperature coefficient based on the data I collected. For the theoretical background, I mainly use two equations. The first one is Ohm's law, which says resistance is the voltage divided by the current. The second one relates resistance to temperature, involving the temperature coefficient. These are the materials I used, and this is the circuit setup for experiment. I worked with 3 different resistors to get a broader range of results. The circuit was set up by connecting the resistor, a multimeter, and a power supply in series. The multimeter was connected in series because it needed to measure the current flowing through the circuit. The main part of the experiment involved recording the resistance at room temperature, then heating up the resistor and recording the new resistance, and finally cooling it down and taking one last measurement. Even though the temperature readings were not perfectly accurate because of small delays or equipment limits, the results still gave a good overall picture of how resistance changes with temperature, and here is the data I collected during the experiment. Normally resistance would increase as temperature rises, but since I used carbon-based resistors which has negative temperature constant, the opposite happened. As the temperature went up, the resistance slightly decreased. After collecting the data, I plotted resistance versus temperature graphs using Python, which helped visualize how resistance changed across different temperature ranges. For each resistor, I fitted a best line through the data points to make the overall trend clearer and easier to analyze. The slope of each best fit line represents the product of the initial resistance and the temperature coefficient. To find the temperature coefficient itself, I divided the slope by the initial resistance value for each resistor. Finally, I compared my experimental results with the theoretical values and calculated the error percentages. Some source of error included inaccuracies in temperature measurement, fluctuations in voltage, and difficulties in keeping the resistor at stable temperature during the process. Despite these small errors, this experiment successfully demonstrated the relationship between temperature and resistance. Thank you for watching.